Alright, in this video I'm going to go through electron configuration. Alright, so at GCSE you were given an oversimplified structure of the atom, and the reason you were taught that structure is because that's all you needed at the time. Now we focus a bit more into the electron configuration, and we learn about something called orbitals. Okay, so at GCSE you're taught that electrons only lie in shells, but the truth is that they lie in something called orbitals. Orbitals are a region in the shell which can hold up to 2 electrons with opposite spin. Okay, so here you have your principal energy levels, right? So this is basically your shells, but the shells can be split into subshells. Okay, so the subshells are an S subshell, a P subshell, a D subshell, and an F subshell. So an S subshell has 1 orbital, a P subshell has 3 orbitals, a D subshell has 5 orbitals, and an F subshell has 7 orbitals. Okay? And each of these orbitals have 2 electrons within them. Okay, so here we can see that the first shell only has 1 sublevel. Okay, so 1 subshell, and it's S. Okay, the second shell has 2 subshells. It has an S and a P, but we know that a P has 3 different orbitals, so it can hold up to 6 electrons. So this one can hold up to 2, this one can hold up to 2, this one can hold up to 6, and the reason is because there's 3 orbitals, and each orbital can hold 2 electrons. So 3 times 2 is 6. So this one can hold up to 2. This one can hold up to 6 again. This one, so a D has 5 orbitals. Each one can hold up to 2 electrons. So 5 times 2 is 10. And then here, this one can hold up to 2, 6, 10. So there's 7 orbitals. Each orbital can hold up to 2, so 7 times 2 is 14 electrons, okay? So the shapes of the orbitals, the S subshell is spherical, and the P subshell is like a dumbbell. Now, personally, I wouldn't spend a huge time trying to visualize this, how this looks with the atom and stuff, because, to be honest, you don't really need to, use this structure of the atom in any other chapter. For other chapters, you can just use your basic GCSE structure of the atom. So it's just to answer these questions for this topic that you need to know orbitals, basically. Every other chapter, you can just use your basic structure of the atom. Okay, so at GCSE, the way you wrote under electron configuration was something like this. And technically, that's not wrong, but it doesn't give any information on how many electrons are in each subshell. So at A-level, you tend to write it more like this, down here. So I'm going to explain how that works. So an atom fills up the subshells in order of increasing energy. Note that 3D is higher in energy than 4s, and so gets filled after 4s. So this is the order of the energies. So 1s, then 2s, then 2p, then 3s, then 3p, 4s, and then 3d, 4p, and so on. We don't really need to know much after this. We don't really need to know this much. Okay. So you fill up the subshells till you have used the right number of electrons for the atom. So if you look at the periodic table, you can see that oxygen has 8 electrons. Now, this small number here, before I explain how to write it down, this small number means the number of electrons in each subshell. Okay, so there's 2 electrons in the 1s. Okay, because I remember we said each orbital can hold up to 2 electrons. There's 2 electrons in the 2s, and then there's 4 electrons in the p. Now, the reason why there's only 4 in this one, because we said before it can hold up to 6. Now, oxygen only has 8 electrons, right? You take away 2, because there's 2 here, you take away another 2 because there's 2 here, and there's only 4 electrons left. Okay, now this can hold up to 6, but since there's only 4 left, we're going to only put 4. Okay, and that's how you write it. So your order is always 1s, 2s, 2p, then 3s, 3p, 4s, 3d. Okay, just like I've written down here. Now just remember here, so this represents our energy shell. Okay, so what shell it's in. So this is the first shell. Both of these are in the second shell. And then here, this is obviously just represents what sub-level or what sub-shell it is. Okay? So it's either S, P, D, or F. Okay. Write down the electron configuration for potassium and neon. Okay, so if you look at the periodic table, potassium has 19 electrons. Okay? So, what we need to do is we need to fill up the orbitals until we run out of electrons. So firstly, we fill up 1s, and that can hold up to 2 electrons. Okay, so I'm going to do 19 take away 2. Now we fill up 2s, so that's 2 electrons, another. Now I'm going to fill up 2p. Now that can hold up to 6 electrons. Okay, so now I'm going to take away another 6. And now I've had 10, so I've only got 9 left. Okay, so now I've got to be careful. So now I'm going to fill up 3s. And that can hold up to 2 electrons. So I'm going to do 9 take away 2 equals 7. So now I've got 7 electrons left. And then I've got potassium. Then I've got another p. So 3p, 6. So I'm going to do 7 take away 6, which gets us 1. And then the next energy level is 4s. And I've only got 1 electron, right? So 4s can hold up to 2 electrons, but since I've only got 1 electron left, I'm only going to fill up 1. Okay. So this is our electron configuration for potassium. Okay? Okay, now neon has 10 electrons. Okay? So this one it should be easier. Now we fill up the first shell, the first subshell, which is 1s, 2, and now we have 8 electrons left. We do 2s2, so now we have 6 electrons left, and now we can do 2p, which can hold up to 6 electrons. So now we have 0 electrons left. Okay? And yeah, this is our electron configuration for neon. Oh, sorry, I was meant to write E. Now, in an exam, this can be kind of time consuming because it's normally only worth like 1 or 2 marks. So if you want to do it quicker, what you can do, so let's say we were looking at potassium because we've already done that. Firstly, it's good to understand how the periodic table works. So this section here, we call the S block, okay? This section here, we call the P block, okay? And then this section here, in the middle, we call the D block. Now, the reason why this is useful is because, so say here, we look at potassium. It's in the S block, right? So we know the most outer energy level is going to be a S. Now, when you fill it up, basically you just fill it up until you get to potassium. So what I'm going to do is I'm going to say, so this is 1s1 over here. This is 1s2, 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Then I get down here, 3s1, 3s2, 3p1, 3p2, 3p3, 3p4, 3p5, 3p6, and then I get down here to 4s1. Okay, so we can just use that to write down the energy levels. So I can just kind of think, okay, so 1s2, because I've filled up both. Then I filled up both of these, so it's 2s2. I've gone through all of this, so 2p6. I've gone past all of these, both of these, sorry. So then 3s2. I've gone through these, so 3p6. And then I finish down here. Okay, so I've only filled up one, so 4s1. Okay, so that's the quick way of doing this. Now let's try it with neon. So neon's right over here. Okay, so in my head I'm thinking, cool, I've gone past these, so that's 1s2. So I'm just going to write down K and neon. So I've gone past those two. Then I've gone past this. So that's 2s2. And then I stop at 2p6. Okay? And that's just quickly the way to do it conceptually. You don't really have to do any maths or anything, so it's just way quicker. Okay, using this method, try write down the electron configuration for calcium and sulfur. Pause the video and have a go. Alright, so for calcium, calcium's right down here. First thing I look at, I go through these two. So 1s2. Then I go through 2s2. 2p6. 3s2. 3p6, 4s2. Okay, and if you didn't realize, so that's just because I went through 1s2, 2s2, 2p6, 3s2, 3p6, and then stop at 4s2. Alright, so that's calcium. Now for sulfur, where is it? It's right down here. Okay, so for this one, I go through 1s2, 2s2, 2p6, 3s2, 3p, and now let's see, 1, 2, 3, 4, okay? Now, sometimes they might ask you for the shorthand configuration, so this is used because writing the full electron configuration can take a while, so we can just use the shorthand configuration to be quicker. So the way you do this, you write down the noble gas before the element and write down the electron configuration for the remaining electrons. So I'm going to use calcium as an example. So, alright, so for calcium, which is down here, the noble gas before it is argon. Okay, now why this is useful, so I can go all the way from here, so 1s2, 2s2, 2p6, 3s2, 3p6, right? But instead of writing down all of that, I'm allowed to just say AR, okay? So if we look up here at all of this, okay, this can be represented by just me saying AR in brackets, okay, in square brackets. Now, I'm only allowed to do this with the noble gases, okay, so just the elements down here in group 8, Okay. And then we have 2 extra electrons, right? So I just need to write that down. So 4s2. Alright? That's quite simple. Now try the same thing out for sulfur. Alright, so sulfur, if we look carefully, it's down here. And the noble gas right before sulfur is neon. Okay? So I'm going to write down neon in square brackets. And then I go through 3s2, 3p4. Okay? So 3s2, 3p4. Now this is just a quicker way of saying this here. Okay? Okay, we can also use spin diagrams to help visualize these electrons. So the arrow represents 1 electron, and each box represents 1 orbital. So like we said before, in each orbital we can fit up to 2 electrons. That's why you see a maximum of 2 electrons in each box. The arrows, you need to make sure they're going in opposite directions if they're in the same box like this. Alright, when filling up each subshell, you need to make sure that you fill up each orbital first before filling up an orbital twice. Okay, so something like this. Something like this would be wrong. Okay? And that's because here you have extra repulsion because the electrons repel each other, right? So in this box there's extra repulsion. And we could just get rid of that repulsion by simply putting an electron here. Okay, so that's what happens. And then, after all 3 of them are filled, then you start to fill up this one again, and then that, and then that. Okay? Okay, so draw this spin diagram for oxygen. Okay, so firstly what I would say is write down the electron configuration. So we have 1s2, 2s2, and then 2p4. Right? So firstly I'm going to do 1s2 because it's the lowest energy level. And this has 2 electrons, so I'm just going to draw them like that. Then 2s2, so that has another pair of electrons. I'm just going to draw like that. And then 2p4 has 4 electrons. Now we have 3 orbitals. And so here we fill up each one slowly, individually first. So 1, 2, 3. And now I can start to fill up this one. 4. Okay? And this is the spin diagram for oxygen. Okay, so the electron configuration of ions. For ions, if you have gained or lost electrons, add the number of electrons the atom has gained or lost to the electron configuration. So I'm going to go through sulfur 2- as an example. So, electron configuration of ions. For ions, if you have gained or lost electrons, add the number of electrons the atom has gained or lost to the electron configuration. So I'm going to go through sulfur 2- as an example. So sulfur has 16 electrons, right? If you look at your periodic table. So if you gain 2 electrons, since it's a -2 charge, you now have 18 electrons, right? So now it has the same electron configuration as argon. So just pretend you're writing down the electron configuration of argon. Okay, because argon has the same electron configuration as S-. Okay, as sulfur 2-, sorry, yeah. So I'm going to do 1s2, 2s2, 2p6, 3s2, 3p6. Okay? Now write down the electron configuration of Mg2+. Okay, so Mg2+, so magnesium has 12 electrons normally, but it's lost 2 electrons because it's a +2 charge. So now it has 10 electrons. Now, this is basically just the same structure as neon now. So I can just write down the electron configuration of neon, which we went through before. It's 1s2, 2s2, 2p6. Okay? Now the electron configuration of D block elements is a bit different when we fill it up. So you just need to remember that we fill up the 4s before we fill up the 3D. And this is because 3D is a higher energy level than 4s. Okay, as we can see here. So write down the electron configuration for nickel. So nickel is right down here. So I'm just gonna, I can use the periodic table tactic, okay? So we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d, 1, 2, 3, 4, 5, 6, so 8, okay? 3d8. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Okay, now there are two anomalies that you need to know for the electron configuration of D block elements. So for chromium, the electron configuration you'd expect it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d4. Right? However, if I was to, I'm just going to write down the spin diagram for this a bit. So this is 4s2, and this is 3d4. Now, in actuality, it's to make it more stable. The atom basically just takes an electron from here and puts it here. Now, I kind of think of this as a seesaw. So if both sides here, if both sides are equal or even, then it's going to be balanced, right? And more stable. Okay? So that's why we do that. So this is only for chromium. And one other example, okay? Copper. So try to figure out the electron configuration of copper. Pause the video and do it yourself. Okay, so for copper, what you'd expect is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d9, right? Now, I'm just going to bring this down here. So if we use this again, so this is what you'd expect. However, once again, to make this more stable, we take an electron from here and put it here, okay? So now the actual electron configurations are like this. So these are the two anomalies you need to know in the D block elements. Okay, now you need to figure out how to write down the electron configuration of D block ions. So when the electrons are filled out, the 4s is a higher energy level than the 3d. Therefore, when removing to form ions, you remove from the 4s first. Okay? So just always remember 4s you do before 3d. Okay, pause the video and try to answer this question and then play it to see the answer. So for chromium, I'm going to write down the electron configuration first. Okay, so this is the electron configuration of chromium. Now, it has a positive 3 charge, right? So we need to take away 3 electrons. So I'm going to take away this 1 electron from the 4s. And then I'm going to take 2 electrons away from the 3d5. So now I've got 3 electrons left here. And this is our electron configuration for chromium 3+. Okay, try do the same for Fe2+. Okay, so for Fe2+, Firstly, I'm just going to write down the electron configuration for Fe. Okay, and now we're removing 2 electrons, right? So we can just remove them both from the 4s2. And now this is our electron configuration for Fe2+. Okay, remember, electron configuration is based off how many electrons you have. F- and Ne have the same number of electrons. Because a fluorine atom has 9, so F- has 10. Therefore, they have the same electronic structure, which has the same electron configuration of a noble gas. Okay, well, H+, if you look at your periodic table, hydrogen has 1 electron. If it loses it, since it has a positive charge, it has no electrons. So this cannot have the electron configuration of a noble gas because it has 0 electrons. Now O-, if you look, it has 8 electrons. Now if we add an electron, it has the same structure as fluorine, right? Because it moves 1 to the right. So now you have 9 electrons. So now you have the same structure as fluorine. And this is not a noble gas. Okay, Se2- has 34 electrons. Now if we add 2 electrons, it has 36. And this is the same number of electrons as krypton. So it would have the same electron configuration as krypton, which is a noble gas. So it looks like this is right. I'm just going to go through D, however, just to make sure. Zinc has a 3D and a 4s, so I'm just going to write that down. So it's a 3D10 and a 4s2. And then I'm going to write down the shorthand configuration. So the argon is the element before it, which is a noble gas. Okay. Now, if I remove 2 electrons, I have a 3D10 on top of this. So this is not a noble gas electron configuration. So Sa2- is your answer.